Okay. Good afternoon, everyone. So I'm aware that I'm standing between you and the next set of coffee and beer and all the rest of it. So I'll try and keep it brief, and if I can't keep it brief, I'll at least try and keep it interesting. So as Thington said, I was here last year, and I gave a talk called Welcome to the Conversation, where I argued that the way we build the Internet of Things has a lot to learn from the way that humans converse and the systems that we've built on the public internet that are based around carrying that conversation, making that conversation more effective, making that conversation resilient. And that was, a lot of that talk was about the sort of the protocol level and the sort of low-level implementation. Today, what I'd like to talk about is the wider world of technologies and ideas that have inspired us in the architecture that we've built as we build Thington. So, start with a quote from someone far more erudite than I. Albert Einstein spent his whole career trying to create a unified theory of the world. So from his first paper in 1900, Folgeren aus den Kapillarien conclusions drawn from phenomena of capillary, to his final paper, to a later paper on the generalized theory of gravitation, he attempted to unify completely separate scientific concepts such as gravity and electromagnetism. And the thing I think that really resonates for me with this is that sense of absolute geek pleasure when you realize that something in two completely different fields is actually the same pattern, the pattern recognition joy that we get from applying something in one field to another. And in 1998, the biologist Edward O. Wilson, known to some as the father of sociobiology, the idea that social behavior and many of the things that we see in society that appear to be completely interpersonal, appear to be completely learned behaviors, that many of those things can be derived from our genetics. And not everyone agrees that he's right, and he caused an incredible storm by implying a sort of genetic determinism. But the thing that I found incredibly motivating about the book that he wrote about this, consilience, which comes from, in the original Latin word, consilience, the derivation means jumping together. When two different disciplines jump together and inform an entirely new idea or an entirely new application. And so today I'm going to talk a little bit about three fairly disconnected areas that, for me, are highly relevant to the Internet of Things, the way we build it, and the way that our products and services could work. So the first of those areas, to me, is the financial markets and financial data. Now, the thing about financial data is it's intrinsically time-based, that the whole financial industry is based around the management, the sharing, the selling, the processing, the privileged access to time series information. And so the financial industry has built up all these incredible tools, these incredible infrastructures for processing it. Indeed, the Bloomberg terminals that have made that company such an incredible amount of money are based on selling access to very low latency information. So the most important thing you can have as a financial trader is to be able to have a piece of information sooner than someone else, so that you can shape your strategy based on it, so that you can shape your immediate actions, and so that you have something that someone else in the market doesn't have. So Bloomberg made incredible amounts of money renting these terminals to people so that they would have this information on every single desk. And something that surprised me, I think is kind of amazing about their business model, was that you can spend more and more money to get less and less time. It's very, very cheap to buy 15 minutes old financial data, and it's incredibly expensive to have a live feed. And this actually extends these days to geography. There's a wonderful TED talk by a guy called Kevin Slavin called How Algorithms Shape Our World. And in it, he describes how buildings like this, 60 Hudson in Manhattan, which is the size of an entire city block, and is where the terminal cables of the internet that come from London, from Singapore, from all over the world, come up into the city of Manhattan and are spread out there through the local internet, and that the buildings surrounding 60 Hudson are being refitted and having all their floors completely replaced with high-density, load-bearing steel, because there is nothing that any one of us could do in any square meter of those buildings that would be more valuable and would generate more money than putting a big rack of servers in there to shave a couple of microseconds off the speed of a trade. And so this kind of information and these flows of information, to me, are intrinsic to the Internet of Things. There is nothing harder to beat as an algorithm than physics. And financial traders have been trying to beat physics for decades in order to make their trades. And we are up against the latency of a light switch on a wall, where you press it with your finger, and as far as we can perceive, results instantly happen. And so I've looked, when I've been building Internet of Things systems, to the tools of the financial trading industry, to the complex event processing category, tools like ESPA, which is open source that comes out of the financial industry. And it turns out that when you're dealing with time series information that is time critical, that actually has a very short window of utility, then working with in-memory data is far more effective than working with on-disk databases. Working with query engines that have a first-class concept of time. I don't want to say select everything from table where some criteria. I want to say select everything from moving average of the last 30 minutes where. And tools from the financial industry allow us to do this. And I first came across this actually in the DevOps community. So I'm sure many of you have screens like this that you use to run your company and your back end, built on backends like Splunk, like Graphite. So there was a great talk about 5 years ago from a guy called Theo Schlossnagel at the Strata Big Data Conference. And his company builds large systems for people and it monitors them. And he said that all the problems they had in monitoring, whether it was counting and making statistics on the data that was coming through it in order to do business reporting, whether it was sort of 1 second latency, a fraud detection, where they work with companies to build interfaces between their e-commerce systems and specialized code to detect fraud, or whether it was something like 10 milliseconds, where you wanted an immediate sense of cause and effect. And in this talk, he highlighted this tool, ESPA, that we've also been using to build Thington, which is an in-memory query engine with a first-class concept of time. And so to me, looking out across the financial industry, which I have never intersected with as a developer, and which is not secretive, but does tend to be somewhat proprietary in the way they retain their tools and tend not to share them across industries, every now and then something has come out from finance that is incredibly useful for building low-latency, real-time systems. So my first of 3 conceptual building blocks for the Internet of Things is that change over time is the essence of Internet data and the essence of building into IoT products. So, to take a 90-degree turn, or much further perhaps, anyone here a World of Warcraft gamer? Just me and you? Okay, cool. Games are incredible these days. I started out playing games when I was 11 years old on the ZX Spectrum, and it was all, it was incredible that they did anything at all. I'm a very casual gamer when it comes to things like World of Warcraft, but friends of mine have been involved in these 40-person battles, this incredible complexity, there's a ton of data. As far as I'm concerned, that's a terrible user interface. In fact, it's something a lot like a Bloomberg terminal. It's a view into a world of data. But the key thing for me here that's different is that this is a world of interfaces and games built for a massive number of concurrent users. So the second thing that occurs to me about the Internet of Things is that traditionally, objects, physical objects in the world, have been single user. They're like the games I was playing on the ZX Spectrum when I was 11 years old. A car, traditionally, has a key, has an owner. If I want you to drive my car, then I must transfer a token to you through physical space. You must take my key or break into my car and steal it. But if you steal it, I can't drive it at the same time either. And there's been this incredible step as technology sort of pervades the physical world, where suddenly these single-user devices are no longer single-user. So my favorite Internet of Things company, I think, is Zipcar. They apply a very small amount of physical technology, an immobilizer, an RFID reader, but everything that they create on top of that simple instrumenting of the car is a service layer that enables something we could never do before. So with a zip car, once a car becomes part of Zipcar, it is inherently a multiplayer car. It is inherently shareable. The credentials for it are inherently transferable. It can be immobilized over a distance. It can be tracked if it's stolen. That car, despite still being 99.99% spinning metal and exploding petrol, that 0.001% of internet attached to that car transforms the use of it for its entire life. So this, to me, is the essence of the Internet of Things. We're turning everything that we've created, every physical product in the world, that by virtue of physics, by virtue of the finger on the light switch, there cannot be more than one finger on that light switch at one time, we have made that device, that thing, inherently multiplayer. And we need to rethink the way that we relate to it as a product, and as product makers, we really deeply need to think about, is this still even the same object? Is a multiplayer car still intrinsically a car in the same way? Or will we bring entirely new possibilities to it? On a different tack, but also with games, anyone remember Secret of Monkey Island? Another of my big favorites over the years. Okay, so more of an adventure game crowd than a WoW crowd here. I think that's reasonable. So the development of games over the decades has really fascinated me. I just, for the very first time in 15 plus years, I've just built a gaming PC at home where I actually ordered like sticks of memory and motherboards and graphics cards, all this kind of stuff, because for the first time in years, there's something that really interests me that requires a very high-end PC, which is playing with virtual reality games. But if you look back over the history of gaming, it proceeds hand in hand with technical capability. And early PC games, like Secret of Monkey Island, that were sort of choose-your-own-adventure, heavily dialogue-driven, they did incredible sort of sleight of hand in order to feel interactive, in order to create a sense that you were in a world and that world was responding to you. And probably not super visible on this TV, they had this dialogue system, which was incredibly rich. So you would end up in a confrontation or an interaction with a character, there'd be some amusing dialogue, you go back and forth, and then you just pick from a couple of choices at the bottom of the screen. And that was an incredibly smart use of incredibly sort of tiny resources, tiny computation resources, tiny storage resources, to be able to store a very simple dialogue tree through a game experience and yet create a feeling that you were exploring a brand new world. That was a real stroke of genius. And it turns out, even though every device you have in your pocket right now is probably 100 times more powerful than the PC that was rendering those graphics, and that we could do incredible things with those devices. Even today, some of the most popular games on the iPhone and the iPad, such as 80 Days, which is really, really nice, elegant retelling of the Round the World in 80 Days story, they're based on these dialogue trees. And as a gamer, as someone who's always keeping an eye on adjacent industries, in case they come up with something cool and interesting that I could use in my own work, I was watching a talk from Inkle, the guys that created 80 Days, at GDC, Game Developer Conference, in San Francisco recently. And they had they'd realized they needed to create sort of tens of thousands of lines of dialogue, that usually these things are deeply integrated with the developers' work, and that the designers and the writers essentially end up submitting change requests to change sort of the odd word of dialogue here and there. It massively slows them down. So they created a system they call Ink, which they open sourced. And it's still not, it's not super designer friendly, but it turns out it's not dissimilar to writing markdown, marked up text, or editing the sort of the markup formatting stuff that they use on Wikipedia to edit pages. And they found that by creating an intermediate language that sat between the complicated back-end systems that were powering their game and the domain of the storytelling that their designers and their editors were in, that they could progress really, really quickly in the world that they were going to create inside their game. And so they open sourced this, And at Thington, we picked this up, and we built a back end based on this that lets our editors and writers work directly with these ink files, not have to worry about redeploying the site, compiling code, working with the developers. And they can bring a personality to our conversation-driven interface that we're building to the Internet of Things. And as a lazy developer who's always proud of the best, the awesome advantage of laziness, which is looking out there, finding something someone else has built, picking it up, and realizing that you can apply it in a completely different domain. I was delighted to pick this up and build it into a system that I hope the game developers behind this code base never thought that their code would be deployed in. So really what I'm talking about here for my second point is that we talk a lot about machine to machine, and there's an incredible engineering effort and incredible amounts of fantastic work have gone into getting us as far as we've got with the Internet of Things. But I think, as has always been with the world of products, the next challenge for making the Internet of Things relevant in every area is the human-to-machine interface. I mean, anything we can do to create tools that helps create a human connection between people and their things, that puts people in the center of the world and makes them feel like they're in control and not the operators of a vast machine, but part of a conversation with their world around them. That's got to be the center of our efforts. So my third point of consilience that I think is highly relevant to the Internet of Things is Twitter. So I'm a huge fan of Twitter. I've been on there nearly 10 years. It has its incredible problems and its incredible advantages as a community. But what I think is so fascinating about Twitter is as a developer, I see it almost as a system of almost mathematical-like axioms. It starts from the simplest of ideas. You can update your status. So this is the notebook that Jack Dorsey scribbled in when he was designing early versions of Twitter. And really, it was inspired by the idea that you could set your status on your AIM instant messenger when you were off doing things, and people would notice. You're like, oh, right, oh, you went shopping today. I couldn't chat to you because your IM said you were away and shopping. Updating those status messages became part of his sort of social fabric of his world. And so, at its simplest, Twitter is 140 characters. Everything about Twitter derives from the idea that we can share an enormous amount of things with 140 characters. And I was reading a history of the first retweet, the first hashtag. And the interview, it was on quartz.com. And they interviewed a bunch of people that had been involved in Twitter in the early days. And as I'm sure many of you know, a lot of the things that are built into Twitter today, like the @ symbol to refer to another user and to mention them and to get their attention, wasn't originally part of Twitter. But users putting this character into those 140 characters, adding semantics, adding meaning to a tweet, created new meaning on top of a simple set of system axioms, extended those axioms to create a more powerful system. And early on, the founders struggled over whether this service was primarily for status updates or for conversation. They argued over whether it was even relevant to have a conversation amongst each other or whether you should just go and write a blog post. And so Twitter grew through a series of paving the cow paths of its users and the way that they fitted new kinds of meaning into very short and simple messages. And I was at another conference in Portland, Oregon, about 24 hours ago, and I was lucky enough to sit down and have dinner with Blaine Cook, the original tech lead on Twitter. And he told me that, many of you will know this, I'm sure, on Twitter. If you start a tweet with @MattB, and then whatever you feel needs to come to my attention, then only other people that follow me will see that tweet in their stream if they follow you too. It's sort of a way of narrowing the huge, the excesses of information that come through the system. And so that reply, there was no special handling of that. It's actually Blaine, the lead developer, that argued that people were being overloaded in their streams with this conversational element, and it was drowning out the status update element. And so he created a system whereby if you start with an @ it's hidden from anyone who doesn't follow the person you are replying. So as they built the system, they extended its meaning, they extended its semantics in response to the way it worked. But still, this was all happening through the medium of 140 characters and then special meaning attached to the way people were using it. And this was the same for all the many of the other things that are now part of the core Twitter product. Retweets were just a thing people did with cut and paste. Hashtag were just a thing you did with a hash character. They didn't have any special handling in the system. The system was extended by use, and then the way it was used was extended by its makers. And I'm very, very interested in sort of the sociological history of systems and the way that use shapes implementation and that implementation shapes potential use. And looking back in the history of Twitter and how they've proposed to extend it in different directions, I found these old slides, kind of pixelated, from a Twitter conference 4 or 5 years ago. So Twitter was proposing to add something called Annotations to Twitter that were only usable by developers. They were to be used by developers to extend Twitter. And the idea was that any tweet could have a little packet of extra information, key value pairs under a namespace. So you might say something like, you might say through your specialist movie app, I am going to see this movie. And your specialist movie app might tweet that with extra metadata saying, movie, arrow, name, arrow, this, year produced equals this, town equals this, and annotate it in a very sort of semantic web kind of way. And that payload of annotations would go with the tweet everywhere it went, and developers of other apps would be able to read, no matter which app produced it, through which API in Twitter, every app would have access to that annotation. So it would start to create a commons of data. What I like to think of I like to think of this as tweets with view source. The idea that there could be a machine-readable layer underneath the human-readable layer. And this would extend the power of the system. And they had some ideas of how you might use this. That things like @replies could be just the beginning. We could come up with new ways, new cowpaths to pave of using Twitter. And so I was really, really inspired by the idea of tweets with view source, that we could have a conversational mechanism, a conversational interface to the world around us that machines could participate in as well. That underneath every tweet could be something my agents could act on my behalf, while I, the human, still remained part of the loop. And so to me, conversation is collaboration. That the essence of human collaboration is in the asynchronous back and forth between many, many people, the ability for conversation to cross many, many media, many boundaries, a large time span. And that we can think of this as a way to build Internet of Things systems. That rather than thinking of everything as a stream of data or everything as a request response, we think of it as sort of infinite conversation built on a commons of data, where we can view source on everything that happens. And so, for me, these three things, tweets with view source, games with rich conversational interfaces, and finance with its time-based data and its sort of incredible complexity boiled down to single points of contact through these terminals, that to me those have been some of my biggest inspirations for Thington, the product that I'm working on. The way I think of this is this quote from Wilson's Consilience. The love of complexity without reductionism makes art. And the love of complexity with reductionism makes science. That as makers of concrete things, our responsibility when we when we look out into the horizon and gather many, many technologies, ideas, and concepts and bring them into our products and our systems, our responsibility as scientists, as makers of hard, solid things in the world, is to apply reductionism to them, to make sure that we don't just get entranced with all this complexity, that we simplify it and bring it together into a simple thing. So as I say, I think the Internet of Things should be a conversation. That's its essence. And that's what we're trying to build with Thington. So, this is not a products talk, but look out for our new version coming in a few weeks' time. I think you'll like it. Thank you very much.